Greetings everyone and welcome to this video on how to perform a paired samples t-test in R. First of all, we'll start by importing a few libraries. The report library is an amazing package to get a formal statistical report, to automate statistical reporting. The ggpubr package is amazing to get data visualization using minimal lines of code. And since we are dealing with repeated measures or paired data, the paired data library is going to help us to visualize paired data points. For this example, we'll be using a data set of 10 type 1 diabetic patients, and we are measuring their blood sugar levels before and after insulin injection. And these are the blood sugar level values for the 10 patients before and after being administered insulin. So we'll be storing these raw data values in two vectors. We are going to name those before and after. And we are going to create a data frame object. We're going to name that df. And we can do so by using the data.frame function. We need to specify the group variable, and we need to repeat the before and after um, names for 10 iterations because we have 10 values of before and after blood sugar levels. And for the BSL variable, we'll be linking the before and after um, vectors. And now we can view our data using the view function. And here the data is in long format, that is, repeated measures are in each individual row instead of separate columns. And we can attach our data so that later on it will be easier for us to call upon these variable names. Now before proceeding any further, we would first like to get a brief overview of our data. So we can do that by using the summary function, which is included in the base R package. And we'll be checking measures of central tendency and variability in data. So right off the bat, we can see that the median blood sugar levels before and after differ by approximately 200 milligram per deciliter, and even the mean blood sugar levels also differ by approximately the same amount. And the interquartile range is quite narrow, so there doesn't seem to be much variance in the data. Similarly with the after blood sugar level values. Before running a paired samples t-test, we would first like to check some assumptions. The first assumption is quite obvious. The samples before and after should be paired. In this case, they are. The sample obtained should be a random sample of the population. We hope so for this data set that this is a random sample. Third assumption is that the sample should be large, that is more than 30. But in this case, it is just 10. And therefore, we would proceed to check whether the difference in raw data values before and after are normally distributed. So this assumption needs to be verified if the sample is not large. So we can do this by calculating the raw difference values and storing it in an object diff. And we can do this using the width function, specify the data frame we are using, and we can do this using this function. And now we can run the Shapiro-Wilk normality test on these values. So remember that a significant p-value in the Shapiro-Wilk normality test indicates that data are not normally distributed. In this case, the p-value is not significant and therefore data are normally distributed. That is a good sign, and we can proceed with using a paired samples t-test. Otherwise, we would have had to use a non-parametric test. To do a paired samples t-test in R, we would use the same function as doing an independent samples t-test with a distinction. We are going to add an argument paired is equal to true. That means we are dealing with paired data. Remember, on the left hand side of the tilde, we have the dependent variable, and on the right hand side of the tilde, we have the independent variable. We'll be storing the results of this t-test in an object ptt, and we'll be calling upon this object using the report function from the report library to automate our statistical reporting. This will automatically give us a very nice report with our mean difference with its 95% confidence interval and a measure of effect size Cohen's d. So in this case, it is a large effect size according to Cohen's 1988 recommendations. We can plot our data using the ggpubr library. The ggline function will give us a mean and confidence interval. We can also specify mean underscore standard error or SE to give us mean and standard error. We can also specify mean underscore SD to give us mean and standard deviation. And we can also plot a box plot using similar arguments as the ggline. And we can see that in the box plot, we get a median and interquartile range. Raw data point outliers are specified by raw data points like these. Now, we would actually like to visualize differences in each individual raw data point. To do that, we'll be using the paired function from the paired data package. We'll be specifying the paired data that is before and after, and we'll be storing that in an object PD to be called upon later. So using the plot function, we'll be calling upon this object PD. Remember that the plot function is included in the base R package, so you don't need to import a specific library for that. And we can also, if we want to beautify the graph, we can also specify if we want it in a different theme. Here we can actually see each raw data point before and after value. We also see box plots which we got using the ggpubr function as well. That's it for this video. Thanks for watching.